This is Priyadharshini, working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to discuss the topic on the mathematical analysis of non-recursive algorithms in the subject DAE. Let's continue. So first we'll see an example. In this section, we are systematically applying a general framework to analyze the time efficiency of a non-recursive algorithm. Let us start with a very simple example that demonstrates all the principal steps typically taken in analyzing such type of algorithms. For example, let us consider the problem of finding the value of the largest element in a list of n numbers. For simplicity, we assume that the list is implemented as an array. The following is the pseudocode of a standard algorithm for solving the problem. So, algorithm name is max element taken in the form of array. The description of the algorithm is to describe the value of the largest element in a given array. The input being an array of n real numbers. Output would be the largest element from the array. So, the pseudocode goes as an assignment statement followed by for loop, and then the maximum value of the element would be written. So, let's discuss. So, the obvious measure of an input size here is the number of elements in an array is n. The operation that are going to be executed most often are in the algorithm's for loop. There are two operations in the loop's body, the comparison a of I greater than maxval and the assignment maxval tends to a of I. Which of these two operations should be considered basic? Since the comparison is executed on each repetition of the loop and the assignment is not, we should consider the comparison to be the algorithm's basic operation. Note that the number of comparisons will be the same for all arrays of size n. Therefore, in terms of this metric, there is no need to distinguish among the worst case, average case or the best cases here. Let us denote C of n the number of times this comparison is executed and try to find a formula expressing it as a function of size n. The algorithm makes one comparison on each execution of the loop, which is repeated for each value of the loop's variable I within the bounds 1 and n minus 1 inclusive. Therefore, we get the following sum for C of n. C of n is equal to sigma I is equal to 1, the upper bound being n minus 1 into 1. This is an easy sum to compute because it is nothing other than 1 repeated n minus 1 time. Thus, C of n can efficiently calculated as sigma I is equal to 1 to n minus 1 into 1, that is n minus 1, which is belong to the big theta of n comparisons. Here is a general plan to follow in analyzing non-recursive algorithm. So, the general plan for this algorithm would be decide on a parameter or the parameters indicating an n input size. Identify the algorithm's basic operation. As a rule, it is located in the innermost loop. Check whether the number of times the basic operation is executed depends only on the size of an input. If it is also depends on some other additional property, the worst case, average case and if necessary best case efficiencies have to be investigated separately. Set up a sum. The next step is set up a sum expressing the number of times the algorithm's basic operation is executed. Using standard formulas and rules of sum manipulation, either find a closed form formula for the count or at very least establish its order of group. Before proceeding with further examples, we'll have a list of summation formulas and rules that are often used in analysis of algorithms. In particular, we use especially frequently two basic rules of sum manipulation. So, these are the different formulas, and two summation formulas also we would be using to check the thing. So, the general plan, finally the general plan for analyzing non-recursive algorithm is we have to first decide on the parameter n indicating its input size, identify the basic operation of an algorithm which should be executed for n number of times for n input. If necessary, if there is any additional property, you have to determine worst, average and best cases for the input size n. Finally, set up a sum for the number of times the basic operation is executed, and then simplify the sum using the standard formulas and rules. This is how the non-recursive algorithms mathematical analysis could be calculated.